The cost of chaos. In modern data org, we aren't just fighting bugs, we are fighting operational friction. Are your senior data engineers spending 40% of their week on data archaeology, digging through upstream mass to find out why our report is broken? Are you hitting SLA breaches because source system changed without heads up? Or worse, is your leadership making multi-million dollar bets on zombie data? The table that looks fine but haven't been updated in last 3 days. If you are leading a data org, I want you to ask yourself three questions. First, is your most expensive engineering talent spending his or her time more on fixing past than building the future? Second, are my analysts maintaining their own private versions of table because they don't trust the central warehouse? Third, if a critical upstream source changed its schema right now, would we find out it in minutes? Or would we find out weeks later when the marketing team or CFO spots a discrepancy? If the answer of any of these is yes, you aren't facing a technical glitch. You are facing data trust decay. If this sounds familiar, your team doesn't have a tooling gap. You have a process depth problem. Adding another observability tool or a Slack bot won't fix the broken data culture or the quality culture. Data quality isn't a post production check like an application which you create and then create test cases. It's an engineering lifecycle requirement. When ownership is vague, by ownership I mean to say data ownership, contracts are not existing between your data teams, and quality gates are bypassed for speed, trust dies. And in corporate environment, once you lose your data trust, it takes quarters, not days to win it back. Today, I am walking you through our production grade data quality assurance cycle. This is how mature teams correct metadata, enforce contracts, and build visibility, which is needed to turn the data from liability into an asset. The first and the foremost thing is automated data capture. Think this like Google Maps for our organization. Without it, your data user teams like business leaders, product managers, marketing, sales, finance, all the teams who are using your data will keep on asking where does this number come from. With automatic metadata, anyone can trace dashboard numbers all the way back to the original source system without calling an engineer. That's why the quality starts before validation. It starts with visibility. And metadata visibility is the foremost thing for increasing the trust in your data. There are many metadata and data catalog platforms available in the market today. In open source category, the popular tools include DataHub, Open Metadata. In commercial or SaaS category, you will often see tools like Collabra, Alation, Atlan, and many more. In today's flow, I'll refer majorly to DataHub, but the same principles apply regardless of which tool you use. So you can use any tool in your organization, and if you're using any of such tools, you're already a step ahead in data quality or data assurance lifecycle. And if not, try to explore one of those tools. I'll be referring Data Hub, but all the principles which I'll be talking about will refer to majority of the tools available in the market. At the first step, we integrate the data catalog with whatever pipelines the system we are already running, be it orchestration tools like Airflow, Oozy, compute platforms like Spark, Databricks, data warehouses such as Hive, cloud warehouses, BI tools that power the dashboards, and source systems like CRM, for example, Salesforce, inventory management systems, and many more. So the metadata should be captured from all the systems along with lineages. I'll talk about that thing later on. And that should be automatically captured. So the goal is pretty simple. As a first step, the catalog should be automatically captured, and it should capture things like dataset schemas, job metadata, ownership information, which is very important, and definitely end-to-end lineages. The second thing is define ownership and data contracts. Just like every product in the company has product owner, every dataset must have one owner. If sales report a wrong number, leadership should know who exactly to contact to fix that. It should not start a blame game to the whole data team. Ownership is a point where most data quality initiative fails. To fix, we should move away from the centralized data teams to adapt domain-based ownership inspired by data mesh principles. Let me browse you through the basics of data mesh, but if you want more details, comment below. I'll create a detailed video on data mesh architecture. So data ownership is defined on a domain base to a domain teams, be it like finance, sales, supply chain, marketing, etc. So each team own their own data. Each domain team treats its datasets as data products, and there's exactly one accumulated owner per dataset. And that one, by that one, I mean to say that team. So think it like your microservice architecture for the data. So when there is a designated owner for a particular data set, and when we start treating data sets as data products, this eliminates the shared responsibility, which in practice definitely means no responsibility. Every data must clearly answer three questions: who owns it? What does correct means? The definition of correct, the definition of the metric, how fresh it must be, what is the SLA to refresh the data. We define data contracts in the same catalog tools like Data Hub with exact details like expected schema, columns, data types, expected row count ranges, freshness SLA, data set criticality like gold, silver, bronze, and the central team, as per the data mesh architecture, is there only to provide tooling, standards, and guardrails, does not define the business correctness or business rules for the data. Those things are defined by the corresponding domain teams. Your data engineer is sitting or working closely with the corresponding domain team. So the hard truth which I want to mention over here is if the ownership is shared, accountability is diluted, and the bad data becomes permanent. And the second most important thing which I normally see missing in the organizations is the metric or a semantic layer. So before even quality checks starts, there has to be a standard semantic layer in an organization which defines the business. Let me explain you. So there are three teams who calculate revenue. And if they're calculating revenue by different methods, I'll explain you in few minutes. All the teams might be correct in their understanding in the way they are calculating the revenue number. But if the same revenue number is visible as three different number into your three different dashboards, the leadership will stop trusting your data. And that's the reason I'm saying another most important thing is semantic layer. So before quality checks, semantic layer should be there, which should standardize the data definitions in the organization. So basically, if I explain you the core principle, the metrics are defined once, Drive metrics must reference parent metrics. They should not re-implement or reuse the same sequels. Quality checks validate both data and metametric logic. For metric layer, again, there are a lot of tools available in the market. The majorly used tool is DBT, what we call DBT metrics. Then there are other tools like local semantic layer, Q, metric flow, and many similar. Or if you don't want to use such tools, you can start using views. Define your SQL or metric in the view and use that. So basically, how does that work? You define the base metrics in your DBT models like revenue, order, active users, conversions, events, and let these metrics be stored into your GitHub and are versioned and have owners defined to them. And the owners are tracked into your catalog tools. And any derived metrics from those metrics should use the corresponding parent metric. So like if I want to drive weekly revenue, that should use the revenue only or revenue metric only. Revenue growth, conversion rates, all these derived metrics should use the parent metrics. And why this matter for data quality? One definition of truth. No copy paste of sequels across teams, what we call duplicate code. Quality checks can be asserted easily because that is being checked into Git. It's easier to figure out the metric level freshness. Does a revenue number get refreshed today? So that's highlight the proper revenue which was generated yesterday. Unexpected spikes or drops in the numbers, consistency between the parent and the child matrices, and many similar things. Let me give you some examples. A very classic example of revenue. Let's say the sales team defined revenue as sum of order amounts, which includes all the orders created, and it could ignore the cancelled or refund orders. And they might be using order creation date for calculation of the revenue. On the other hand, finance team could define revenue as sum of paid amount rather than order amount. They could exclude refunds. They could they could only include the successfully paid orders, not the orders which might get cancelled or there are errors in the order flow, basically the payment flow. And instead of using creation date, they might use the settlement date. On the other hand, the marketing team could use the revenue as some order, but they could include only the new customers, might be customers added in last 30 days, 60 days. So all the teams, when on their dashboard, they define revenue as a number, they are correct in their jobs. But a different revenue number visible onto three different dashboards will drastically reduce the trust, and it reduces the trust drastically onto the data by the corresponding users of the dashboards, majorly your leadership team, sales, marketing, and many similar teams who are your data customers. But if we define the metric, revenue metric, as a standard metric by the corresponding team who handles the revenue, definitely the finance team, in this case, the metric is defined at the organization level. Any team who want to use this metric will use the corresponding metric, will not rewrite or reinvent the revenue sequel. So, and if we ensure that part, the leadership knows whom to contact for the revenue metric. They know the corresponding revenue owner. They also can backtrace the metric from the catalog tool, and that increases the trust in your data. It's easy to reconcile, it's easy to run tests at the metric level. So once you've defined the data ownership, or I could say the metric ownership, by using the data mesh architecture, now it's easier for us to define the data quality checks. And let me explain you why. Finance teams knows when the revenue data is wrong. Marketing team knows when the campaign data looks suspicious. Rather than letting a central data team define all the checks, which is like asking IT to approve accounting rules, we should have the corresponding data owners define the corresponding data quality checks for their data domain. Data quality, what I mean to say, data quality cannot be completely centralized. Each domain pod owns data quality logic, writes quality checks close to the data. The written quality checks, or I would say SQL code, should be versioned into Git. For all these things, you can use, there are a lot of open source tools like Great Expectations, Soda Code, DQ by AWS, DBT tests, which are basic but pretty effective. For my today's flow, I'll be referring Great Expectations, but all the other tools also give the similar capabilities. Why these tools works well? Because you can define your testing logic, which can be easily versioned into Git. Then these definitions can run easily inside your batch or streaming pipelines, or I would say can be easily integrated with your orchestration tools like Airflow or Spark jobs, Databricks jobs, CI/CD pipelines. If you've never used tools like Great Expectations, let me tell you what are the beauty of using them and how easy it is to start with them. With tools like Great Expectations, you can just provide a sample of your real data and the tool can auto profile your datasets. That is, it can automatically generate initial set of test cases like schema checks, null rates, ranges, distributions, and many more things, which can easily integrate as a starting point and then keep on refining and defining them along with the domain level logic, which tool will not write for you. And definitely AI can do it. This dramatically reduces the effort to get started and avoid writing test cases from the scratch if you're using tools like Great Expectations. And the common checks which I would like to emphasize, which you should embed with the help of these tools, or basically embed in the pipelines, are like schema drift detection, null rate thresholds, primary key uniqueness, value range validations, distribution drift checks, referential integrity wherever applicable, and many similar things along with your domain checks. And these should be ran along with your pipelines, and the ownership to run them, that they run up properly, is then done by our centralized. So once we have defined the quality checks, we have to define the quality gates. Think it like an airport security. If something fails, the security, or if someone fails the security protocols, security guidelines, he does not board the flight. Similarly, bad data should never reach dashboards just because the pipeline ran successfully. Quality checks must run when data actually moves in your pipelines, not as a side job. While Airflow, Databricks are common to apply this logic, but the same pattern applies across any stack. Quality gates can run in orchestration definitely with Airflow or Argo, CI/CD, and similar things, along with your code which is running inside your compute engines like Spark, Databricks, Flink, or Beam. They can run into your transformation layers like DBT, They can even run in a streaming systems like Kafka or Flink, validating data at the window level. So think of running your quality checks at each and every layer. Think it like the airport security. Do not allow data getting bored up if the pipeline ran up without any errors. Run the quality checks. The pattern is simple. After every ingestion or transformation step, run the data quality test or test suits, capture whether it passed or failed, record the key matrices as we have defined up in our quality checks like row counts, null percentages, freshness timestamp, runtime, and many similar things. If any of the critical checks fails, the pipeline must stop there itself. It should not only stop when the Spark job gone out of memory. Downstream tasks should not run. Downstream tables should not be overwritten. Dashboards should not be refreshed. If a non-critical check fails, the pipeline can continue. You have to define what is critical and what is not critical. But the issue must be logged and notified. The key message here is bad data should fail fast at the pipeline boundary and should never be propagated silently to the downstream of the pipeline. When the quality checks from tools like Great Expectations are pushed into your data catalog system, such as Data Hub, something important changes. Business users no longer need to ping data engineers asking, is this table safe to use? Or I would say, is this table safe to use today? They can instantly see the green or the red trust patch showing the data freshness and quality, just like a verified check mark for the data. And this is critical because data quality without visibility is useless, as I said previously. So along with the badge, the catalog exposes the real signals like certificate status, which I'll talk about later on in the quality lifecycle. The last process timestamp, quality score, the time of last successful check. And at this point, the data catalog stops just being a documentation tool. It becomes a metadata store, a quality registry, and the most important, the clear trust signal for data consumers. That means when the team stops debating numbers, start using the data more confidently. Once the metadata and end-to-end lineages are auto-captured in data catalog like Data Hub, debugging data issues become visually possible and intuitive. When dashboard numbers look wrong, users don't panic or ping engineers. They simply trace where the number came from, like tracking a package from the warehouse all the way to your doorstep. This is where the real data trust is built. Using lineage views, users can see the complete journey of the data, source system, ingestion pipelines, transformation jobs, final tables, and the dashboards. If anything broke in between, if today the data from Salesforce did not came up, you can easily track it to the final dashboard. At every step, each node shows a clear trust signal, data quality badge, freshness status, last successful run. All these things increase the trust onto your final dashboards. The user journey becomes simple and logical. Start at the dashboard, if required, drill down to the table, follow the lineage, review the full quality or quality history. No Slack messages, no pings to your data engineers, just increases and rebuild the trust and confidence in your data. And the next most important thing is alerting and observability. If the payroll data is delayed or incorrect, leadership should not hear it from employees, HR, business teams, or via angry Slack messages. Someone needs to know immediately, and that someone should be the right operational team or operations team and not the business users. That's why we say failures must notify humans, should not be sitting quietly into the logs. In a mature setup, data quality and freshness metrics are exposed to monitoring systems like Prometheus and visualized in Grafana dashboards or whatsoever observability tools you are using up. This allows data platform, DevOps, and SRE teams to continuously track data freshness SLAs. Are they met? Did pipeline fail? Repeating quality issues over time? And clear alerts could be defined up, for example, payroll data set, freshness, breaches, it's 2 hour SLA. A critical validation might be row count, schema, null checks, fails. The same pipeline failed 3 times in a row. When any of these conditions trigger, alerts are sent immediately to the corresponding data owners, and now we all know the owners of data. There is no centralized data team. The data platform or L2 support teams or supporting those things via your PagerDuty or Slack or whatsoever you're using up. So instead of business users discovering the issue at 9 a.m. in the morning next day, the data platform team is paged at 4 a.m. in the morning, and a corresponding action could have been taken before or proactively so that the trust remains there, observability is properly met. If nobody gets paged, nobody fixes the data. Pretty simple. As I mentioned earlier, data quality checks must be embedded directly into data pipelines. But there is one point that deserves extra emphasis. Just like code reviews prevent software bugs, data quality checks in pull requests prevent broken data logic from ever reaching production. Bad data should be stopped before it runs in production, not after dashboard breaks. In a well-designated CI pipeline, data quality checks are automatically executed whenever schema changes are introduced, transformation logic is modified. If critical validation fails, the pull request is blocked and cannot be merged. This guarantees that schema changes are intentional and are not done without proper thought process. And that's exactly how the data platform should operate, with guardrails and not firefighting. And the most important part, certification lifecycle. Certified data is like an audited financial statement. It is trusted because it consistently met clearly defined standards, what we have defined in our previous steps. Certification is not something someone manually declares. It must be earned automatically and continuously based on how data actually behaves over the time. Let me give you an example. Certification criteria might require that there are zero critical quality failures over the last 7 days, and the data freshness always stays within the agreed SLA. All these things we have defined in the previous step. When these conditions are met, and we have also looked into how to run these conditions, the dataset is automatically marked as certified. A certification badge appears in the data catalog, the central data catalog, which you have defined up. If those conditions are violated, certification is revoked. And automatically the stakeholders are notified. So the key idea is simple. Dataset or a metric can only have a certificate associated with it as long as the data quality exists with that. And last but not the least, enable customers to discover the data. Instead of chasing people on Slack just to understand a number in a report, data users should be able to find answers at one place, our data catalog. Because data quality means nothing if the customer experience is poor. For example, imagine a product manager looking at daily active users dashboard and notice a sudden drop. Without a good data experience, the next steps are familiar. Ping your analyst onto the Slack. Data analyst then pings the data engineer. Engineer checks the pipeline. Hours are lost just to understand the correct context. With a proper data catalog experience, the flow is very different. On the dataset page, the dataset which you have defined up, users can immediately see a sample query showing how the metric is calculated, clear schema definitions, and the field level descriptions. The dataset owners and support persons are clearly defined over there. The complete data quality and freshness history is defined over there. All the dashboard reports that depend on to these datasets are also available over there. So if something is not correct or looks incorrect onto your, let's say, daily active users chart, the users can raise the issue from there itself by a single click, which can create a Jira ticket. So the outcome is pretty simple. The data discovery is defined pretty well. The data is documented, and with the checks, quality teams can trust all the metrics and can rely to them. So let's quickly recap all the 9 steps. The first important thing is make the data visible by capturing the catalog along with the lineage of the data from the source system till the end dashboard. Assign clear ownership for the data, break the data from the centralized team into a data mesh architecture so that you can define the clear data owners. Agree on the definitions first, define your test cases properly, define your metric, have a proper metric layer like DBT, validate data automatically in your data pipelines, block the bad data as early as possible by running the test cases by using tools like Great Expectations so that the bad data never reaches your dashboards or reports. Show test signals clearly. Users should instantly see if the data is correct, certified, when was it last refreshed, alert the people on time by integrating your data pipelines with our standard in-house observability tools. Certify what is reliable, notify if the certification breaks, and make it easier for users to find and understand the data by properly documenting it. So data quality is not a single tool, it's a closed loop. Metadata, ownership, contracts, checks, gates, visibility, alerting, and certification. Are you using all these practices or some of them? Which steps are missing in your organization right now? Do you think this will actually solve the data quality or trust problems? Comment below what could be added more to this cycle, or if you disagree with some of the points, because data quality isn't theoretical, it's painfully practical. Thank you. Thanks a lot for listening to me.